Okay, graphing quadratics. I taught you the shortcut, but let's just do this the way that we did it for most of the time. Negative b over 2a. And so the axis of symmetry would be negative 8 over 2, because it's 2 times 1, which is 2. So that's negative 4. And then you make a table of values. We're just going to do 3 values here. So let's do negative 4. Normally I'd have you do 5. But we'll just plug these in. So if I plug in negative 4 for x, I get negative 19. And then if I plug in negative 3 and negative 5, I should get the same thing, which is 9 minus 24 is negative 15, negative 18 for these. So 1, 2, 3, and let's pretend that this is negative 19 down here, which would be negative 18 right here. So my parabola is going to open up and look like this. All right, simplifying square roots. What times what is 50? That's a perfect square. It's 25 times 2. So that's 5 radical 2. What's a perfect square here? It's 49 times 2. So the answer to this one would be 7 radical 2. And for this one, we got to make sure we simplify the variables as well. So the 50 becomes 5 and 2. But now x to the third, remember, you always leave one behind if it's an odd. So if I took one out, that's x squared. Square root of x squared is x. Now, that should be a y. Y to the 8th, that's even, so that's just y to the 4th. We'll leave none inside. And the last slide, this is called right here. These steps are called the quadratic formula. Okay, so I plug in 1 for A, 6 for B, 8 for C, plug them into the square root symbol, simplify what's inside the square root symbol. Square root of 4 is 2, and then I do negative 6 plus 2 divided by 2, and negative 6 minus 2 divided by 2. So my final answers for x would be negative 4 plus 2 is, negative 6 plus 2 is negative 4, divided by 2 is negative 2. And negative 6 minus 2 is negative 8, divided by 2 is negative 4. That's quadratic formula.